So today we'll be starting on a new chapter, that is wind power plant. So so we'll be taking up the things, that is the introduction to renewable sources, need of wind power plant, why we are needing this wind power plant, then site selection, then what are the factors that are to be considered for selection of site for wind power plant, then what is the operating principle for wind power plant, then what is the working and how is the power is generated in the wind power plant, then its merits and demerits, like its what are the advantages or disadvantages for this, and then last is your present scenario. What is the scenario means how much of we can say we are energy deficit in the can say field of wind power sources, and how much we are producing, how much we are planning to produce in the next coming years, in the coming future in this case. So let's start. So first is your why we are opting for wind power. We are having, we can say, many options like solar energy, hydroelectric power. Here we have a lot of options for this. We can say thermal energy we can use for this thermal storage parts. Then why wind power has always given us necessary propulsive force to sailing ships and has also been used to run windmills. So as we know, it's one of the oldest form and it is being used for the sailing of ships. Yes, and it is also being used to run windmills. Windmills are basically that the mills that rotate on the we can say by blowing of winds, and that is to be converted into when the rotation of windmills is being converted into your energy, or you can say power for this case. However, the recent attention paid to climate changes, the demand to increase the amount of green energy and fear of decrease of oil fuel in the future have promoted a renewed interest in production of electrical energy from renewable sources and also from wind power. So, as far as now, like there have been changes in the climate, where and there is, we can say, enormous increase in the demand of your green energy. So as we know, the population is going up, so as the need, so as the demand for energy is also going up. Where so and we have to that let it to be going for a green sources of energy rather than going for, we can say, conventional forms like from thermal power. Yes, so it is thermal, coal, petroleum, we can say. So that the sources are, we can say, they are producing the energy, but they are not the green form of energy. And most importantly, they are being using the fossil fuels, and that fossil fuels will get, we can say, extinct in some of the time, and to replenish them, it takes a long course of time. And as compared to this green energy, we have to shift from the, we can say, conventional sources to non-conventional sources, or from we can say conventional sources to green sources. That is because the green energy is demand of the hour, like today for us. And so the horizontal axis wind turbine with upstream three-blade rotor has resulted to be the most suitable typology, and consequently has found a remarkable development characterized both by quick grown in size and power as well as by a widespread. So what we normally call it that is horizontal axis wind turbine. So that is an upstream three-blade rotor turbine. Here it is having three blade and upstream it is working, and it is considered one of the most suitable, we can say, form, and so that to generate energy, and that is also characterized by quick grown size and power, as well as it is very much widespread, is extensively used. We can say the model for this is that is called, that is horizontal axis wind turbine. So generalities on wind power plants, physics and nature of wind. So what is wind, how it is generated, means what is the source of we can say generation of wind. The earth continuously releases into atmosphere the heat received by the sun, but unevenly. So as we know, earth is getting heat from the sun every time, and as it is receiving from the sun, clear, so it is releasing that heat onto the atmosphere also, but that we can say the release is not even, like it may be more at some parts, it may be lesser at some parts, so it is not an even release basically. In this areas where less heat is released, two layer zones the pressure of atmospheric gases increase, whereas the more heat is released, air warms up and gas pressure decreases. So then basically what happens is that some of the areas is there we can say more heat is released, and in the some areas lesser heat is released. So the area where less heat is released, the pressure normally the atmospheric gases increases. The pressure on the atmospheric gases that is relying on them it gets to increase. Whereas in the case of your heat, we can say where the more heat is released, air gets warm and it goes up. As we know that when we heat air, it gets lighter and moves up, and the gas pressure on this basically it tends to decrease the gas pressure in this case. So what is happening as we see this is A, this is B, this is the red one is the heat. Like this is the in the white arrows that is the heat coming from the sun. This is our earth. These are the places where the sun where the wind is basically the earth is the points where earth is releasing the heat. Clear? So from B part it is the hot with the areas of more heat release. These are A are the areas of lesser heat release. So what is happening is that is due to there the areas of we can say a difference between the lower heat release and more heat release that leads to decrease or increase in pressure at some places. So that is the reason why there is a pressure difference is generated in this. Since atmosphere tend to constantly re-establish the pressure balance, the air moves from the areas where pressure is higher towards the pressure is where, as we know, it is the principle from air pressure from the air moves from the area of higher pressure to the area towards of lower pressure because the atmosphere is constantly trying to we can say create a balance in between this, and it tends to creating a balance. What is happening is there is we can say air is moving from the zones of high pressure area to the zones of lower pressure area. Therefore their wind is in the movement of air mass. So that movement of air basically to get from the atmosphere to get established we can say balance in this case that it tends to generation of wind in this case. Clear? More or less with between the zones at different pressures. So it will be moving from higher pressure to lower pressure, and that zone basically it can be depending upon the balance that is to be established by the we can say atmosphere. So that helps us to we can say moving of winds from like from zones of high pressure to low pressure, and that is basically the generation of wind, and that wind can be used for movement of our windmills, and that can be again be used for generation of electricity in this case. Where the profile of unevenness of the surface of the dry land or the sea deeply affect the wind and its local characteristics. In fact, the wind blows with higher intensity on large and flat surfaces such as sea. This represents the main element of interest of wind power plants on and offshore. So we generally see that wind power plants are located generally near the shore, on shores or offshore. Yeah, so we can say the prime reason for this is basically due to the large and a flat surfaces basically that tends to become the we can say the intensity of wind increases in that part. So that is basically the characteristics, local characteristics of that wind. Because being a flat and open area, we can the intensity of wind increases near the seashore, and that is a reason, major reason for we can say employing wind power plants near the offshore beaches. Moreover, the wind gets stronger on the top of the rises or in the valleys oriented parallel to the direction of the dominant wind. And another, the we can say surface topology is also important in this case. Like winds normally get stronger when they're in the top of rises or in the valley. Like in the valleys, it gets higher in the case or stronger in that case. Then, whereas it slow down in uneven surfaces such as towns and forests. So when there is uneven forest, like there are buildings and obstructions in the path of the wind, is basically like if it is a forest, it will be having trees in the path. If it is a town, it will be having a bigger buildings in its path. So what happens is that obstructions in the path of the wind leads it to fall its we can say the intensity of the wind gets down in this case. Or uneven surfaces like we have mountains in the place or when like uneven surfaces up and down and surfaces that also tends to create obstructions in the path of the wind, and that tend to relieve we can say its intensity is being lowered in this case. clear, uh, and its speed with respect to the height above the ground influenced by the conditions of atmospheric stability. So that is all these conditions are basically affecting the, we can say, the atmospheric conditions for that atmospheric stability of wind in that case. Now, if we start for a site selection for your wind power plant, so what will be are the key points that would be taken in the most important decisions throughout your installation. So whenever we have to, we can say install, or we can say we are planning for a wind power plant. So the most important decision is the installation basically. So the vital part is the performance and efficiency of turbine, because the site selection is among the most important part in this case. High exposed sites, like we normally prefer that is exposed sites to the, we can say, to wind to wind here. So not suitable sites in highly populated residential areas, as we have discussed before also, because populated areas or high rise buildings are basically a form of obstruction in the path of wind. So that we can say obstructions tends to lower its intensity, and that places are not suitable for, we can say, installing of wind power plant on that parts. Then avoid roof mounted turbines. We normally avoid the turbines mounted on the roofs, because there is a lot of turbulence in this case, because when there is the movement of this your wind turbine, it gets to, there is a lot of vibrations onto the your towards the bottom of this layer. So of the nasal is basically the body for this. So all its, we can say, movements of the, we can, disturbances are yet to be absorbed by the body where it has to be installed. If it is, and if it is installed on the roof, that may be unstable for a building in this case. So power transmission loss is another factor, because if we go too far away from the load center, then the problem of power transmission loss is always there, because as long as the distance we are moving, or we can say we are moving away from load center, because we have to go there, there will be the cost of, you can say, transmission lines. There will be the cost. There will be the cost of, like, employing poles over that part, the boots over that part, maintenance over that part for a long. Secondly, when there is, we can say, if it is a longer area, so then there will be the losses will also be high in this case. So that is an important point for this. So then distance between the turbine and the nearest obstacle. So next is an important point, like where the turbine is installed here, and the nearest obstacle, the distance between them is also a crucial part of this also. Then connection with national power grid. So how long it is being connected, means how the distance for this for the connection of national power grid that we were talking of. We have to put off the, we can say, the lines for this, and that lines are to be taken associated for this particular decision for this. Now next is the working principle for the wind turbine. So wind turbine operate on a simple principle, like it is working on a simple principle, that is wind is merely air in motion. Like if we talk in a general terms, what is wind? It is air that is in motion, that is wind. So wind turbine converts kinetic energy from the wind, clear. So it is converting the energy from the wind sorry, kinetic energy from the wind that passes over the rotors onto the into electricity. So there is, if we call out that is, like it is the movement of due to the motion, kinetic energy is the motion possessed by body due to its motion. So when it gets that, we can say the motion of this that on the form of kinetic energy from the wind that is onto the rotors, and that is the movement of this. It is being connected to the generation of electricity. The kinetic energy of the wind turns 2 to 3 propeller-like blades around the rotor. There are normally 2 or 3 blades in the we can say windmill, where or the rotor that is rotating. The rotor is the rotating part, where the rotor is connected to the main shaft, and that rotation of rotor is connected to the main shaft. That will be the rotation is being transmitted of the rotors. The rotation of rotor, if is being transmitted to the shaft of the main shaft in this case, where which spins the generator to create electricity. So what is happening? The rotors are connected to the main shaft, and the main shaft is connected to the generator. So as the rotor moves, there is a movement of main shaft, and then as the main shaft moves, there is a rotation of generator also. Where that is the part of generator. When the generator is moving, it is generating electricity in this case. Wind turbines are mounted on a tower to capture the most energy. So normally the wind turbines are captured on a tower, and normally we put it on a tower or install it on a tower to capture the most of energy, because the aim of for this is to maximum amount of, we can say, rotation of rotors in this case, and that will happen if the maximum we can say use or harness a maximum amount of wind energy at 100 feet, like it is for 30 meters or above ground. They can take advantage of faster and less turbulent wind. So as the height increases, the turbulence in wind also decreases. Clear? So at normally if we take off like 30 meters in this case above ground, that is we can take the advantage of faster air, and that too is also less turbulent wind in this case. Then wind turbines can be used to produce electricity for a single home or building, or they can be connected to electricity grid for more widespread electricity distribution. So depending upon our needs, depending upon the installation, depending upon the, we can say, cost, depending upon the capital invested here. So it can be installed for a single home, like we can have it for a home individually for a home itself, like it will be generating a load of near about consumed by a home here, or it can be there is one turbine or several turbines connected to the grid for the, we can say, combined generation of combined electricity, and that is to be supplied later to the homes in this case. Then wind turbines harness the power of the wind and use it to generate electricity. Yeah, it is but stated. Simply stated that wind turbine works the opposite of a fan. Instead of using electricity to make wind like a fan, wind turbines use a wind to make electricity. So if we talk in a general terms, the like these are working in the opposite of a fan. Like when fan is rotating, it is providing us the air. It is providing us the wind, but that is consuming electricity. But it is in the case of vice versa. In the case of your wind turbine, due to the rotation of the wind turbine, there is generation of electricity in this case. So that is extremely opposite of a fan. While in the case of fan, by the rotation of the we can say fan, we are getting the air, but that is consuming electricity in this case. But in this is opposite case, by the air, the fan is rotating, the rotor is rotating, and by the rotation of rotor, the electricity is produced. So if we call it, they are extremely opposite of a fan to the wind. Then what are the parts of your wind turbine? Here, what are the various parts of wind turbine? Like hub controller, pitch cylinder, main. These are named over parts over this. Yes, we'll be taking on one by one over this part. Like here we see. So the first one is your. In this case, it is the name of the parts. Now let's see it in the figure. So this is first, that is blades. Then second is your, these are the blades at the number 1 part. Then second is the rotor. This is the rotor part on designated on number 2. Then third is your pitch. That is the pitch, basically the movement of the blades that normally we call it yaw, pitch, roll. There are 3 motions that we study. So this motion is pitching of this, so it will be moving in this direction. Yes. So air will be going on like this direction. So this is the direction of wind. It will be gliding over the blades in this pathway. In this direction, it will be gliding over the blade and let it to move over this. Then fourth is the brake. This is the part of a brake that is like when we have to stop it or reduce the, we can say, movement of your windmill. That is the brakes are used in this case. Then low speed shaft. That is your fifth rank. This is low speed shaft. This is connected directly to the rotor. Here, so this is low speed shaft. Then sixth is your gearbox, that is connected to gearbox. Gearbox is basically to reduce or increase the speed. Basically for this, that is gearing is being used in this case, or to control it on a controlled manner. To use wind in a controlled manner, we are using it. Then 7 is generator. This is generator. It is connected to main shaft. This is main shaft and connected to generator. And with the rotation of rotor, the main shaft is rotating, and the rotation of main shaft, generator is rotating, and with the rotation of generator, we can say it electricity in this case. Then it is controlling connected to controller on this part. This is 8. And then it is 9 is anemometer that is controlling. We can say air for this. We can say movement of air is being known in this case. Then wind vane that is telling us the direction of wind in 10. Then 11 is nasal. Nasal is your over this part, that is the whole body. Over we can say that is constituting the whole of the part. That is your shaft, blade, rotor, brakes, that gearbox. All are being generator. All is being constituting in a nasal in this case. That is the whole body that is covering all over this. That is nasal. Then it is high speed shaft that is on 12 tank that we were discussing. It is connected directly to the generator. This is high speed shaft on this page, this one here. Then it is your drive that is on 13 rank, that is here. So yaw pitch rule that we were talking about this, that the movement is controlled the yaw manner in this case. Then yaw motor, then for the drive there is yaw motor in this case. This is connected to this. This is on 14. This is yaw motor that is the rotation on, like there will be a rotary motion of the, we can say, windmill, and that will be sliding on the direction of this. So it is being controlled by yaw motor in this case. And 15 is the tower that is being grounded to the, you can say, ground in this case, station to the ground. This is basically your tower. So these are basically major parts for the wind turbines in this case. So next is, so now these are the parts that will be discussed one by one. So wind turbine consists of 4 main components, like it has the rotor, it has transmission system, generator, and yaw control mechanics control system in this case. So what is rotor? A rotor consists of a hub, 3 blades, and a pitch regulation system, all of which are located upwind on the tower. So we see here, so this is rotor here. So this is a rotor that is a rotating element upon this. So it consists of a hub and 3 blades. So this is hub and 3 blades. So this is constituting a rotor in this case. There, and a pitch regulation system. So how it is being regulated in this case, all of which are located upwind of, and they are located upwind top of the tower. The blades are airfoils which depend on the aerodynamic lift, and to move the blades and cause rotation, air moving of the blades causes negative pressure on the upper side and positive pressure on the lower side. This causes the rotor to rotate. That we were discussing in the direction of the air. So it is what is happening. Air will be passing on to the, we can say, to like they are at an angle. Normally the blades are at an angle over this. So when air is passing, it will be getting off, and it will be passing over the airfoil, or the, you can say, the angle provided onto that blade. Yes. So it is providing negative pressure on the upper side and positive pressure on the lower side of this. Yes. So that causes the rotor to rotate, because it has to be balanced. Like if the negative pressure on upper and positive pressure on the lower side, then only it will be the air will be gliding on from the aerodynamic action or the aerofoil. So airfoil will be passing over this, like as we see the blades of our fan also, in the fans also, they are, we can say, tilted at an angle. So that is to get the aerodynamic action here. So airfoil, that is to create a, we can say, a negative pressure and a positive pressure, so that the rotation is possible in this case also. Then next is your transmission system. The design speed of the rotor is 16 rpm. Normally the design speed is 16 rpm, although it can be increased also for certain cases. Then transmission system is the mechanical power generated by the rotor. There is the mechanical power that is generated by the rotor blades and is transmitted to the generator by transmission system. So it is the, we can say, the power generated by blades due to their motion is called basically your, and it is controlled by the system of, that is your transmission system. This consists of a gearbox, braking system, plus the auxiliary lubricating and cooling system. So it is consisting of a transmission. It is having gearbox, braking system, plus auxiliary lubricating and cooling system. The gearbox is needed to increase the rotor speed. So what is it is happening is, it will be gearbox normally, as we have discussed, to increase or decrease the speed of this rotor. Yes, increase the speed 16 rpm to 1800 RPM speed of that generator. So that is basically by the help of braking and we can say the engagement or disengagement of gears by in the gearbox, we can increase the speed from 16 RPM to 1800 RPM here of that speed of generator in this case. The braking system is designed to lock the rotor when shut down. So normally braking system is used when we have to shut down the rotor or the lock the rotor, so that if the air is wind is also blowing also, then also it won't move or rotate in this case. Then